So we covered the first three sections there, brief history, what is a DT, where is the research? What I want to do now is really to build on some of the previous section where we started to talk about taking a more holistic perspective or systems view, perhaps rather than the bottom-up nuts and bolts, and introduce a systems view, and then we'll move on to the final section. So to do this, I'm going to start with some observations around when and why do we actually twin. First one is we twin because the systems are where a system is dynamic, so the condition, behavior, inputs, environment change over time. We also twin perhaps when the system is high value or safety critical, i.e. it can't fail or go wrong. Think about aero engines or aircraft engines or critical infrastructure. We also twin when we want to avoid downtime, cost undesirable states and quite complex processes, things like bottlenecks in production systems. We might also twin where system control or intervention is needed, but cannot easily or exhaustively be codified in or onto the physical. So here you might again think about the nuclear power stations as an example. The fifth one there is we might twin where system models are limited and there's a need for those to be supplemented by real world data. This is either to improve the models or the models cannot actually represent the real world. And that's a particular challenge where people, or for socio-technical systems where people are involved, so the built environment, for example. And the final driver or motivation is often where the scale and complexity is such that it's difficult or impossible for humans to comprehend the system in a tractable time scale to take an action. So really it's all about this systems perspective. And if we step back and we can make a number of propositions about the digital twin and from a systems perspective. First one is that the digital twin allows a generation of understanding. That's what it's about. It's about understanding to aid decision-making and control. The second one is that the digital twin is not static. It is alive. It's continually evolving and changing. The third one is that the digital twin allows experiments to be conducted without impacting the physical system. So you can conduct experiments offline in a safe environment. Again, think about nuclear power stations. Any learning needs to be conducted really offline. The fourth one is that the digital twin system is a living learning loop, continuously generating understanding or knowledge for the owner or users. And these are sort of what I would call as the characteristics of the digital twin system. And we talked earlier, right at the beginning, about John Vickers' original definition when he talked about living models. And I think that speaks to some of these characteristics. So if we go back again and let's look at the whole, our original definition, we can now say it's a living learning loop, and we can look at the whole, not just the individual parts. And if we look at the whole and apply design thinking to this, we can ask questions: what are the requirements or purpose of this loop? What insights do we need, and when do we need these insights? What confidence or precision do I need in my insights? What data do I need, and when do I need the data? What models are needed, and what level of confidence do I need in those models? How is feedback to be implemented? How do I interact or control the system? And then one that we've not talked about much is how to evaluate cost benefit. How do I appraise the value of this digital twin system and the potential benefit? Armed with this more of a systems perspective, researchers across the globe are starting to look at the digital twin from more of a design or systems perspective, asking questions like, how complete does it need to be? What latency is acceptable? How precise do I need things? How accurate do I need the data? And this is an example from some of our work as a research group, looking at the fidelity of the digital twin and defining our requirements for fidelity given a particular application. Not going to go into huge detail about that today.